Good day everyone! My name is Mara Rafael and I will be discussing information technology industry and kasama ko ang team ko. So as we all know, ngayon sa modernong panahon, we use technology. Sa kahit anumang aspeto ng buhay ay ginagamit natin ng technology hindi lamang para mapadali, kundi mas nagiging productive ang mga ginagawa natin sa pang-araw-araw. So basically, technology plays a crucial role, especially sa panahon natin, lalo na kapag may mga ginagamit tayo sa pang-araw-araw na gawain, pati sa school, pati na rin sa different trabaho like computers, the phone, different laptops na nakaka-help para mas mapadali yung trabaho natin. And that is why information technology industry exists. Good day everyone, my name is Mara Rafael and I will be discussing information technology industry overview, the different companies under it, maging ang mga economic factors for the information technology industry, what makes it successful, and the different regulation about IT industry. So, let's start. But before that, let's discuss kung ano nga ba ang pinagkaiba ng computer industry and IT industry. Alam natin na computer industry and IT industry are both connected to each other. Pero meron silang pinagkaiba. Computer industry, dito kasi ay nakafocus sila sa different software, different hardware like motherboard, different peripherals of computer like mouse and keyboard, na kung saan sila yung nagda-develop and nagma-manufacturer. So without this company, ay hindi natin mapapadali kung ano nga ba yung ginagawa natin sa pang-araw-araw or hindi natin magagamit yung sinasabing technology. And dito, sa computer industry, pwede ko siyang i-compare sa sasakyan. And para mapagana ng sasakyan, we need a driver. So, dito papasok si IT industry. Si IT industry naman ay nakafocus siya on the different services, the different solution na makakatulong sa different hardware or different proponents of computer na kung saan without IT technology ay mahihirapan tayo sa paggamit ng mga different na products na ginagawa ng computer industry. That is why they are both connected. Kasi nga, kung si computer industry ang parang foundation of the technology, kailangan niya ng driver para gumana siya. And siya ang ikino-consider nating driver, which is yung IT tech industry. So, that is why connected sila. Moreover, sinasabi kasi rito na industry and IT industry are both connected. Just like what I said kanina, na with technology, nagiging madali ang lahat. Sa lahat ng aspeto ng buhay, sa lahat ng pang-araw-araw, nakikita natin ang technology na ginagamit para maging productive, para mapabilis, para mas mapadali yung mga trabaho natin sa paggamit pa lang ng cellphone, printer, lights, etc., etc. We need technology. But sometimes, mayroon yung ibang tao na nakakaligtaan na kapag gumamit lang daw ng computer, they're part of the IT industry, which is wrong. Because, ang una dapat nating titignan ay yung core business ng different companies na yon. An example is, ang isang bangko ay gumagamit ng computer for computing and for data analyzing. However, that doesn't mean that they are part of the IT industry. Sinasabi dito na ang computer ay tanging instrumento lamang para mapadali yung trabaho nila, but they are still part of the finance industry. So that is why industry and IT industry are connected or interchangeable, because with technology nga, nagagamit natin siya into different companies or into the different industry. Ganon. So that is the industry overview. And with with the IT industry ay meron tayong tinatawag na parang convergence. With convergence, we integrate different companies to create more. With convergence, we integrate different technologies to create more powerful and useful solution. Ayun ang pinakapunto ng IT industry. Kaya siya interchangeable. Kaya interchangeable ang industry and IT industry because of convergence na tinatawag. An example is yung Apple. So basically, the Apple company offers their hardware like the MacBook and iPhone, and nag-offer din sila ng software like iOS and cloud assistance, Apple Assistance for technical service, ganon. So that is an example of IT industry. Next, the different companies included in the IT industry. So basically, it was divided into different division na kung tawagin ay sectors or segments. So the first one is we have equipment manufacturers. The equipment manufacturers ay sila yung create or nagde-design ng different hardware like PCs, mainframes, and networking gear. So basically, without this, mawawala ng paglalagyan ang software. So, it's very important, or ito yung nagiging body of technology na tinatawag. So, with the equipment manufacturers, they play a crucial role. Kasi nga, kung walang hardware, mawawala ng silbi ang software. Next is the chip makers. They also play a crucial role because they create a chip na kung saan ang isang chip ay nagko-contain ng billions and billions of transistors na kung saan sila yung nagko-command sa isang gadget. An example is a microprocessors na kung saan ito ay a small process of unit, a very small processing unit inside the CPU na kung saan siya yung nagsisilbing brain. We also have the RAM and the circuit boards as the memory card, parang memory of that gadget. Next is software publisher. Another lang pala sa chip makers, mahalaga din kasing tinitignan natin yung chip. Sila yung gumagawa ng chip na kung saan kapag bibili tayo ng bagong gadget or phone, we check first if anong chip yon, kung anong meron, kung Intel or AMD. Pag sinabing Intel, it is a single core performance na good for gaming or for application lang. Pero pag sinabing AMD, it's good for multitasking or heavy gawain na ginagawa sa isang gadget. So that's it for chip makers. Next is software publishers. With the software publishers, they make our project, or it makes our everyday life productive, especially kapag nasa office ka. Because dito sa software publishers, they are the creators of operating systems and various applications. An example of it is the creation of MS Office. Diba? With the MS Excel, nagagamit siya para mapadali yung computing, especially sa school. Mas napapadali yung pag-compute. Kasi i-code mo na lang, ay nalalaman na kung ano yung average ng isang student na yon. So that is for software publishers. Next is service companies. Providers of support, the consulting, web hosting, and repairs. So basically, with the software publishers, sila yung nagsusupport, nagma-maintenance ng different technical solution. So basically, ito yung mga web hosting, security, and they make sure na maayos yung mga serbisyong may offer nila. Kasi nga, sila yung more on na nag-assist. Pag sinabi yung web hosting is parang dito, na ilalagay yung different website sa sa World Wide Web. And of course, for security na rin, lalo na kapag merong sa kanila, nag-avail, parang sa isang bangko, kailangan nila ng service companies na kung saan make sure yung security ng kanilang kliyente, like the data. Next is Next and last is the computer retailers. Computer retailers, also known as reseller, na kung saan there's no need for middleman. Pag sinabing middleman kasi, ito yung mga resellers. I mean, sila yung wala nang middleman. So, basically, they have a direct sale representative. So, yun. Yung sa computer retailers. And with this, ay mas napapadali yung gap or merong bridge between or wala nang bridge between the manufacturers and the end-to-end users o yung mamimili mismo. Next is the economic factors. Basically, sinabi sa module natin na IT industry is very dynamic, very prosperous, and it fueled the different economy from the different countries. Hindi siya OA kasi very, very malalaman natin siya or very nakikita natin siya sa kung paano natin nagagamit yung cellphone. So, example is yung paggamit natin ng e-commerce, yung different technology, etc. Sinasabi rin kasi dito na IT industry is a conglomerate. Pag sinabing conglomerate, it is a giant corporation with different companies that offer different products. Kumbaga, kapag nawala or nalugi yung isang kumpanya nila, hindi pa rin sila nawawala ng profit. And nagkakaroon dito ng diversification. So that is why IT industry fueled the economic factors or it fueled the different economic of the different countries. Example na lang, the Japan and Germany na gumagawa ng different cars with the technology na nag-exist na pwede nang i-avail sa IT industry ay yung simpleng paggawa, yung kotse na umaabot ng weeks or months, nagtatagal na lang siya ng araw. And with this, tumataas yung GDP nila. And yun kung paano naapektuhan ng technology or IT industry ang economic factors. Another one is the e-commerce. Diba kasi yung different small vendors natin, pwede na silang gumamit ng mga Shopee, Lazada, etc. to sell their products. And doon, nagkakaroon kasi ng tax na siyang backbone of the economy ng isang country. So, that is economic factors. Example pa pala sa economic factors ay yung isang company na Hitachi, Japanese company, ay isa siyang conglomerate company actually. Kasi sila yung mga gumagawa ng chip makers, biggest chip makers, and nag-offer din sila ng different technology or services, something na ganon. Na kung saan, example na lang, yung isang hospital bumili ng MRI machine sa kanila. And at the same time, ay pwede rin silang mag-offer ng different services dun sa mga nurses or parang ano na yun, kung paano gamitin yung machine na yun. Parang training na rin. So, they offer an end-to-end solution. Parang meron ng masasagot na nila lahat. And yun yung reason kung bakit conglomerate ang IT industry. Tapos, dito rin kasi papasok yung sinasabi nilang ano na yun? Para makontrol yung supply chain ng isang company. Next is, what makes IT industry successful? So, dito papasok ang pressure, competition, and yung demand ng mga tao. So, as time goes by, tumataas na rin yung mga different demands natin. Kumbaga, kailangan natin makipagsabayan sa globalization, kailangan natin makipagsabayan sa mayayamang bansa na kayang mag-afford ng mga different products or high-tech na kagamitan like the Japan, or like the America, ganito ganyan. And dito, papasok yung competition na tinatawag. Example, sa different company. Ang isang sari-sari store ay tumaas yung kita, kaya umabot sila sa isang grocery store, sabihin na natin grocery store, na sana yung may-ari ng manual counting. However, sa dami-dami ng competition ng mga kalaban niya outside the market, ay inside the market, ay malamang sa malamang, kailangan niyang mag-afford or kailangan niyang humingi ng service sa IT industry para mapadali yung manual counting, yung accurate na pagsukli, and yung mga resibo or different codes for it. That is why mahalaga yung IT industry. Lalo na, kaya nagiging success siya. Kasi nga, if yung sari-sari store na yon, yung dating sari-sari store na yon, ay hindi bumili ng ganong products or service, ay mapag-iiwanan siya, malamang sa malamang, malulugi siya dahil wala nang pipilang mga customer niya kasi nga mabagal, hindi accurate yung pagsukli, kulang-kulang, ganito, ganyan. So, that makes IT industry successful. Another one is yung innovation. Just like what I said, is kailangan nating nakipagsabayan sa iba't ibang bansa. Kaya na-pressure yung gobyerno na bumili ng different products para makasabay yung ating bansa sa different countries, lalo na kung with this technology ay makaka-attract tayo ng different foreign investor. So that is why that makes in the IT industry successful. Another one is yung sa pressure na tinatawag ko, dahil kung yung kalaban mo bumili na ng ganitong products, mapapressure ka, wala kang choice kundi bumili ng ganitong products para makabenta ka rin, para pagpilian ka rin. So, that's it. Next is marketing channels. Marketing channels, yung pagbebenta ng different IT products ay meron na siyang different channels na or branches na tinatawag. And dito, papasok si computer retail stores. Si computer retail stores kasi, ito yung physical company or physical store na nakikita natin sa kalsada, sa daan, or etc. na madali lang natin puntahan. Dito, yung mga stuff, may knowledge sila about sa mga certain products. So, malamang, good siya for the beginner na gustong magtanong kung ano ba yung bagay sa kanila as a student, as a college student, as a teacher, etc. And pwede rin nilang makita kung meron bang issue yung certain product na bibilihin nila. Next is the mail order or internet outlets. Goods naman siya for tech savvy. Lalo na kung marunong silang tumingin kung meron bang mali sa product na yon, etc. Pero ito, mako-consider siyang cheapest kasi nga wala naman silang binabayarang upa, kumbaga mag-ipapadala na lang nila. Just like yung paggamit na ng Shopee, Lazada, etc. Nakakakuha ng advantage dito yung mga small vendors kasi naipopost nila through internet yung different products nila. So, tataas na naman yung So, nakaka-contribute sila sa pagtaas ng ekonomiya ng Pilipinas. And at the same time is, para sa mga hindi masyadong lumalabas, ay mas napapadali sa kanila yung pagbili ng different products kasi isang search na lang nila, titignan na lang nila sa comment section kung may issue ba or wala, ay mas napapadali yung pagbili nila. Next is the value-added reseller. So basically, it combines commercial products with proprietary tech for custom system. So, eto kasi, nag-offer sila ng ready-to-use. Kumbaga, gaya ng sinabi ko kanina, value-added reseller, just like what I said, is meron na silang pwede, kapag may binili ka sa kanila, meron din silang service na mag-i-offer. Or kumbaga, merong end-to-end solution. Next is the manufacturer's direct. So, dito ay walang middleman. Kumbaga, ay meron silang direct sales representative na kung saan pwede dito pumili ka ng bulk prices. So, example, ang isang university ay umorder sa Android ng hundreds of computer. So, pwede pa silang makakuha ng discount. So, that is manufacturer's direct. Yung mismong kumpanya mismo. So, last is the industry regulation. So, with the industry regulation, papasok kasi dito yung government regulation, yung different organization na binuo ng mga trade and professional organization, and lastly is the standardization. So with the government regulation, syempre, hindi naman pwedeng papasok lang sila ng papasok ng different technology. Chine-check muna nila yung encryption algorithm, kung nakakasama ba siya sa gobyerno or ginagamit ba yun ng different criminals like na for para makagawa ng mga masasama. So, dun, with the government regulation kasi, ay nagkakaroon ng limitation yung different IT industry leaders. That is why they created the Trade and Professional Organization. Ito yung mga different leaders na kung saan ay ino-oppose nila minsan yung different regulations by the government. That is why they created some organization na kung saan nagtutulungan sila or tumutulong sila sa authority kung ano ba yung mga different companies or mga gumagawa ng illegal para ma-report nila and para maprotektahan na rin yung intellectual property. So that is the Trade and Professional Organization. Example nito is yung software and information industry. Lastly is the standardization. So, niisip nyo ba na yung different phone natin, kahit magkakaiba ng brand, like iPhone, Samsung, etc., pwede pa rin tayong connect sa isang Wi-Fi. That is because of standardization. Nagkasundo or nagkaroon ng consensus na kung saan dapat ay merong sinusundan na pamantayan kapag gagawa ng different gadgets or different technology. Dapat ay pare-pareho siya para kahit papano ay ma-access pa rin natin. Kasi paano na lang kapag yung isang tao ay ko-connect sana ng Wi-Fi pero hindi sila same ng brand ng Wi-Fi. That is the standardization. Kahit na may pagkakaiba sa different characteristic ng isang technology, ay kailangan meron pa rin silang sinusunod na standardization na pasok sa public. So, that's all.
So, ayan, dumako naman tayo sa mga profession and careers in the computing fields. Unahin muna natin, ano nga ba muna ang computer professionals? Ang computer professionals ay tumutukoy sa mga isang tao or sa tao na ang pangunahing trabaho ay may kinalaman sa computer, lalo na sa pag-design, pag-setup, pagsusuri, paggawa, at pag-ayos, pag-test, pag-secure ng hardware or physical na bahagi ng computer. And software naman is ito yung mga program or apps. So sa madaling salita, ang computer professional ay sila ang mga eksperto na gumagawa, nagpapatakbo, nagproprotekta ng mga computer system para gumana ito ng maayos at ligtas. So next, preparing for a career in the computer industry. Una, choose your computer area. So, bago ka pumasok sa industriya ng computer or sa larangan ng computer, mahalagang malaman muna kung anong larangan interesado ka or magaling ka. Halimbawa, pag-programming, IT support, networking, or cybersecurity. Yung mga yan. And after that, kapag malinaw na sa'yo ang gusto mo, mas madali mong malalaman kung anong mga kasanayan at kung anong dapat pag-aaralan mo at kung anong mga subjects or course ang tututukan mo. It is like, for example, kapag may pupuntahan kang isang lugar na hindi ka familiar. So, ang una mong gagawin, aalamin mo muna kung ano ang direksyon bago ka maglalakbay. So, sa pangalawa, dito naman ay nakatuon or mas nagpo-focus sa practical na pagsasanay o mga hands-on na activities kaysa puro lecture. Dito ay agad kang hinahanda para sa isang particular na trabaho sa computer field tulad ng technician o basic IT roles. So, lastly, sa college or kolehiyo, mas malawak at mas malalim ang itinuturo tungkol sa computers at technology. Dito, hindi lang skills ang matututunan kundi pati mga konsepto at mga theories. Dito sa college or university, kapag kasi nakapagtapos ka, maaaring magbigay ng mas maraming oportunidad sa trabaho at mas mataas na posisyon sa hinaharap or in the future. Next is the 6 main areas of jobs. Una dito ay ang management. Ang management sa larangan ng computer jobs ay tumutukoy sa mga taong namumuno at gumagabay sa paggamit ng teknolohiya sa isang organisasyon. Pangalawa, ang system development and programming. Ito naman ay tumutukoy sa mga taong gumagawa at nag-aayos ng mga computer system at software. So, sa madaling salita, silang utak sa likod ng mga program at system. So, ang pangatlo naman ay ang technical services. Ito ay ang mga taong nagpapatakbo at nag-aalaga sa mga technical na bahagi ng IT system ng isang organization. So, ang pang-apat ay ang operations. Ito ay tumutukoy sa mga taong nagpapatakbo araw-araw sa mga computer system at network ng isang organization. Mga taong nag-ooperate at nagmo-monitor kung maayos at stable pa nga ba ang mga takbo nito. Ang panglima naman ay ang training. Ito ay tumutukoy sa mga taong nagtuturo at gumagabay sa mga empleyado kung paano gamitin ang mga bahagi ng information system. At ang panghuli naman ay ang security. Ang security ay tumutukoy sa mga taong nagproprotekta sa data at information ng isang organization laban sa mga hindi autorisadong gumagamit. Hindi lang sila basta naglalagay ng mga password. Sila rin ay gumagawa ng mga patakaran or policies tungkol sa tamang paggamit ng systems at data. So next, let's proceed to different job titles and their functions under the 6 main job areas. First is the management. Under the management, there are 3 job titles and their function. First is the Chief Information Officer or Chief Technology Officer or E-Commerce Director. Ito naman ay ang tumutukoy sa mga pinuno na nangangasiwa at nagdidirekta sa information services at communication system ng kumpanya, tulad ng email systems, databases, networks, at online platforms para siguradong maayos, ligtas, at epektibo ang paggamit ng teknolohiya. Ang pangalawa naman ay ang Network Administrator or Wireless Network Administrator. Ito naman ay tumutukoy sa mga taong tagapangalaga at nagpapatakbo ng network ng kumpanya tulad ng LAN, WAN, wireless, internet, intranet, at sila rin ang nagre-resolve ng mga problema sa connection para tuloy-tuloy at maayos ang komunikasyon at online operations ng isang organization. Ang pangatlo ay ang project leader or project manager. Ito ay tumutukoy sa mga taong nangangasiwa sa lahat ng proyekto ng isang team or ng isang organization. Sila ay ang nag-a-allocate ng mga resources, gumagawa o tumutulong sa mga system analysis at programming, nagre-review sa mga performance ng mga miyembro o empleyado para siguraduhing maayos at epektibo ang takbo ng proyekto. So next is the System Development and Programming. Under the System Development and Programming, there are 5 job titles and their functions. Una na dito ay ang Computer Games Designer o Programmer. Ito ay tumutukoy sa mga taong gumagawa at nagde-design ng computer games. At isinasalin nila ito ang kanilang mga design sa aktwal na laro gamit ang kanilang mga tamang computer programming language tulad ng paggawa ng mga characters, movements, levels, at game mechanics. Ang pangalawa ay ang computer scientist. Ito ay tumutukoy sa mga taong nagsasaliksik, nag-iimbento at gumagawa ng mga bagong solusyon para sa mga komplikadong problema o pangangailangan ng software, tulad ng pagdevelop ng bagong algorithm. Yes, algorithm, artificial intelligence, at di kaya data analysis tools na makakatulong sa mas mabilis o efficient at mas mahusay na computing. Pangatlo ay ang database analyst. Ito rin ay tumutukoy sa mga taong nagsusuri at nag-oorganisa ng data gamit ang mga data modeling techniques at tools para masigurong tama, mabilis at epektibo ang paggamit ng data sa isang application o system. At ang pang-apat naman ay ang desktop o mobile application programmer or developer. Ito ay tumutukoy sa mga taong ginagawang aktwal na program ang system design gamit ang tamang computer language tulad ng Visual Basic Java, yung C tapos hashtag tapos F then hashtag at C tapos plus plus. Basta yon. Then, para makagawa ng software o apps sa computer o mobile na maayos at gumagana ayon sa plano. At bilang panghuli naman ay ang web software developer. Ito ay tumutukoy sa mga taong nagsusuri, nagde-design, gumagawa at sumusuporta sa mga web applications gamit ang mga tools at languages tulad ng HTML, Ajax, JavaScript, at multimedia para maging interactive, maayos, at user-friendly ang mga websites or web apps. Next is the technical services. Under the technical services, there are 9 job titles and their functions. Una na rito ay ang computer technician. Ito ay tumutukoy sa mga taong nag-aayos at nagpapaayos ng computer at software. Halimbawa, kapag may sirang computer o mabagal na program. Siya ang humahanap ng kung ano yung problema sa system and at the same time, nag-aayos para gumana ng maayos ang system. Next is database administrator. Ito naman yung mga taong nangangalaga sa database ng kumpanya. Halimbawa, siya ang gumagawa at nag-update ng data dictionary at tinitiyak na mabilis o efficient at maayos gumana ang mga database para laging available at tama yung mga impormasyon. At ang pangatlo naman ay ang desktop publisher or compositor. Ito rin ay tumutukoy sa mga taong naglilista at nag-aayos ng teksto at larawan para makagawa ng handa ng gamitin na publications tulad ng brochure, posters, o newsletters na maganda at madaling basahin. Pang-apat naman ay ang digital forensics examiner. Ito ay tumutukoy sa mga nangangalap at nagsusuring mga tao ng mga ebidensya mula sa computer at network. Halimbawa nito ay ang kapag may nangyaring cybercrime. Siya ang tumitingin kung saan galing ang problema at ano ang nangyayari para malaman ang sanhi at makahanap ng solusyon. At ang panglima naman ay ang graphic designer or illustrator. Ito naman ay tumutukoy sa mga taong gumagawa ng visual na disenyo para sa mga produkto or serbisyo. Halimbawa, siya ang naglilimbag ng mga poster, logo, o ad materials na kaakit-akit at madaling maintindihan ng mga tao. Bilang pang-anim naman ay ang quality assurance specialist. Ito naman ay tumutukoy sa mga taong nagsusuri ng programs at dokumento para siguraduhing tugma o tama ito sa standards ng kumpanya. Halimbawa na lamang nito ay ang kapag tinitignan nila kung maayos at walang errors ang software bago ito gamitin o ilabas sa publiko. At ang pang-anim naman ay ang storage administrator or analyst. Ito naman ay tumutukoy sa mga nangangalaga sa mga storage system ng kumpanya. Halimbawa na lamang nito ay siya ang nag-i-install, nag-maintain, and nag-upgrade ng storage at tinitignan ng data ay tinitignan kung sapat at maayos ang pagkakaayos ng data para laging available at ligtas ang impormasyon. Next is the web designer. Ito naman ay tumutukoy sa mga taong gumagawa ng visual at graphical content para sa websites. Halimbawa na lamang nito ay siya ang naglilikhang graphics gamit ang Photoshop, Flash, at iba pang gamit ng Next is the web designer. Ito naman ay tumutukoy sa mga taong gumagawa ng mga visual at graphical content para sa websites. Halimbawa na lamang kapag siya ang naglilikhang graphics gamit ang Photoshop, Flash, at iba pang mga multimedia tools para maging kaakit-akit at user-friendly ang website. At bilang panghuli naman ay ang webmaster or web administrator. Ito naman ay tumutukoy sa mga taong nangangalaga at nagpapatakbo ng website ng kumpanya. Halimbawa kapag siya ang nag-aayos ng web pages, tumutulong sa mga users gumawa ng mga pages, at tinitiyak na mabilis o efficient at maayos gumana ang website. So, next ay operations. Under operations, there are two job titles and their functions. Una na rito ay ang computer operator. Ito naman ay tumutukoy sa mga taong nangangalaga sa computer equipment sa araw-araw. Halimbawa, siya ang nagmo-monitor ng performance, nagpapatakbo ng jobs, at gumagawa ng mga backup or restore para sa siguradong tuloy-tuloy at maayos ang operasyon ng system. And next is the data communication analyst or VoIP specialist. So, dito naman tumutukoy sa mga taong nangangalaga sa communication system at nangangalaga sa mga communication system ng kumpanya. Halimbawa na lamang nito ay siya ang nag-i-install at nagmo-monitor ng mga equipment at software at tinitiyak na maayos ang internet ng WAN connections para tuloy-tuloy ang komunikasyon. Next ay ang data communications analyst o VoIP specialist. Ito naman ay tumutukoy sa mga taong nangangalaga sa communication system ng kumpanya. Halimbawa na lamang nito ay kapag siya ang nag-i-install at nagmo-monitor ng mga equipment at software at tinitiyak na maayos ang internet at yung WAN connections or yung WAN para tuloy-tuloy ang maayos na komunikasyon. And next, the training. Under the training, there are job titles 7 and their functions. Una na rito ay ang IT, CS, IS instructor. Ito naman ay tumutukoy sa mga taong nagtuturo ng mga estudyante tungkol sa mga computer science at information technology. Halimbawa, tinuturuan nila kung paano mag-program, gumamit ng mga software, o intindihin ang computer system para maging handa sa trabaho sa IT. Pangalawa ay ang corporate trainer. Ito naman ay tumutukoy sa mga taong nagtuturo sa mga empleyado kung paano gamitin ang software at gumawa ng system. Halimbawa, tinuturuan nila kung paano mag-design, mag-develop ng mga programs at gumamit ng mga computer tools para mas maging epektibo sa trabaho. Pangatlo ay ang help desk specialist. Ito naman ay tumutukoy sa mga taong sumasagot sa mga tanong tungkol sa computer. Maaaring personal, sa telepono o sa chat. Halimbawa kapag tinutulungan nila ang mga users kapag may problema sa software, password o connection para mabilis itong masolusyonan. At bilang pang-apat naman ay ang Chief Security Officer or CSO. Ito naman ay tumutukoy sa mga taong nangangalaga sa pisikal na seguridad ng kumpanya at sa kaligtasan ng mga empleyado. At siya rin ang nagproprotekta sa mga computer system at data laban sa mga panganib o laban sa mga panganib or mga darating na problema. Halimbawa na lamang dito is kapag tinitiyak niyang ligtas ang opisina at secure ang network at databases. Panglima ay ang Computer Security Specialist o Mobile Security Specialist. Dito naman tumutukoy sa mga taong nangangalaga sa seguridad ng data at impormasyon sa mga computer at mobile devices ng kumpanya. Halimbawa, siya ang nagse-secure ng files, apps, at networks para hindi ito ma-access ng mga hindi autorisadong tao. So, ang pang-anim naman ay ang Network Security Administrator. Ito naman ay tumutukoy sa mga taong nangangalaga sa seguridad ng network ng kumpanya. Halimbawa, siya ang nagko-configure ng mga routers at firewalls at nagsiset ng web protocols at enterprise ng technologies para protektado laban sa mga cyber attacks at maayos ang connection. So, bilang panghuli, ang Security Administrator. Ito naman ay tumutukoy sa mga taong nangangalaga ng seguridad ng buong kumpanya. Halimbawa na lamang nito ay siya ang nag-aayos ng mga access permissions, nagmo-monitor ng mga system, at pumipigil sa mga hindi autorisadong pag-access para protektado ang data at resources.
Reyna Juloy sa Advincula, and today I'll be discussing the computing domain and computing disciplines. So, this topic may sound technical at first, but let's try to understand how computing concepts actually work together and how they are used in real life. So, let's begin with the computing domain. So, number one, computer theory. So, computer theory is not about coding yet. Before we write any program, we ask an important question. Can this problem even be solved by a computer? Because if a problem is impossible to solve, then no matter how good we are at coding, we're just wasting time. So that is why computer theory exists. First bullet focuses on how problems are solved. When we say how problems are solved, we don't mean typing code. We mean what steps are needed, in what order, and will those steps actually work? Think of it like planning a route before traveling. Diba, before we drive, we actually plan first. So, second bullet studies efficiency of algorithm. Now, even if a problem can be solved, the next question is how fast can it be solved? So, some solutions take seconds, some takes years. And computer theory helps us choose the fast and practical solutions. So, determines if a problem is solvable. So, this is very important. So, some problems look simple, but they need infinite steps or even impossible calculations. So, computer theory helps us identify this early. So, instead of struggling for months, we already know this problem has no solution at all. So, next, as I've said, avoids wasting time on impossible tasks. So this is where theory saves time, money, and effort. So in real life, companies don't want trial and error forever. What they want is certainty, and computer theory gives that certainty. So next, uses models of computation. So a model of computation is like a pretend computer. Why pretend? Because our real computers are complicated models. So this let us focus on ideas, not machines. So this helps us test solutions cleanly and clearly. Next, measures time and resource use. So resource means time, memory, processing power. So even if something actually works, if it's too much memory or time, it's not useful in the real world. So next, foundation of computer science. So everything in computing like algorithms, software, AI, security, and all of them stand on computer theory. So without theory, computer science has no direction. So next slide, this is the sub-areas. So computability theory. The question would be, can this problem be solved at all? Next one, complexity theory. How fast and how expensive is the solution? Next one is formal languages. How computers understand symbols and instructions. Let's go now to number 2, algorithms. Now let's talk about algorithms. An algorithm is simply a step-by-step way of solving a problem, just like a recipe. If you follow the steps correctly, then you'll get the correct result. So first bullet, step-by-step problem-solving methods. So this means an algorithm has an order, cannot skip steps, and must be clear. If a step is confusing or missing, the computer gets confused too. So computer don't guess, so they only follow instructions. So core of all computer programs. So every program you see, like apps, websites, games, all of them are made of algorithms. Without algorithm, software does nothing. So designed for accuracy and efficiency. Accuracy means the answer is correct. Efficiency means it doesn't take too long or it don't waste resources. So a slow correct answer can still be a bad algorithm. Different algorithm for the same task. So one problem can have many solutions, many algorithm, but not all are good. Some are slow, some are fast. So computer scientists compare algorithms to the best one. So some are fast, some are inefficient. So some are fast, some are inefficient. Like what I've said, this is very important. Just because an algorithm works doesn't mean it's useful. If it takes hours, days, or even years, then it's impractical. So computers execute algorithms well. We know humans get tired and make mistakes, while computers repeat perfectly and follow rules exactly. That's why algorithms are made for computers to execute. So combined algorithms form programs. So a program is not one algorithm. It's many small algorithms working together. It's like organs in our body. So examples, bubble sort. This one compares one by one. If it works, but it's very slow. It's inefficient for a large list. So it's good for learning, but it's bad for real use. We have another, merge sort. This divides the list into smaller parts. So sorts them, then merge them back. It's faster, more efficient, and more practical. And we have Dijkstra algorithm. So this finds the shortest path. Example, Google Maps, GPS navigation, but it only works if there are no negative paths. So that only shows algorithms have limitations. So algorithms are powerful, but they're not magical. They work only within rules and under conditions. That's why choosing the right algorithm matters. Now let's move on to cryptography. Cryptography is the science of keeping information secret. So it's about making sure that only the right person with the right key can read the messages. So science of encrypting data. So encrypting data It means changing information into a form that looks meaningless. So to anyone else, it's just like a random symbols. But to intended receiver, it can be turned back into real information. So protects private information. So think about bank account numbers, passwords, private messages. So without cryptography, anyone could read them. So cryptography exists to protect privacy. So used in networks and storage. So cryptography is used when data is sent, like in online, and when data is stored, like in hard drives or database. So protection doesn't stop after sending. It continues even when data is at rest. So why cryptography is important? First, protects data online. So when you log in, send messages or shop online, cryptography is working silently in the background. So prevents hacking. Hackers usually look for unprotected data and weak security. So encryption makes data useless to them. Even if they steal it, they can't understand it. So secures communication. So this ensures messages are not altered and identities are verified. So you know who sent them the message and that it wasn't changed. So risk in cryptography. Now here is the danger. Homemade encryption is risky when people invent their own encryption or don't follow standards, or they often make mistakes. And one small mistake can break the entire security. And bugs weaken security. A bug is not an error. In cryptography, a bug is an open door. So attackers look for bugs to bypass security. So use standard algorithms. That's why expert says don't create your own encryption. So instead, use tested, trusted, and standard algorithms. They have been reviewed, attacked, and improved over time. So modern systems are really broken because encryption is weak. They are broken because people use it incorrectly. Let's go now to number 4, distributed computing. So distributed computing is a type of computing where one big task is divided into smaller parts, and these tasks are shared across multiple computers. So these computers are connected through a network, usually the internet. So they work together at the same time. So because the work is shared, problems are solved faster compared to using just one computer. So it's like imagine you have a very heavy project. If only one student works on it, it will take a long time. But if the project is divided among many students and each one finishes their part, then the work is done faster. So that is exactly how distributed computing works. So how distributed computing works? So first, the system takes one big problem and breaks it into smaller tasks. So each computer in the network is assigned one task. After all the computer finish, the system collects and combines the result to produce a final output. So no single computer gets overloaded. So example of distributed computing. So one real life example of distributed computing is folding at home. So it is a project where people from all over the world allow their computer to help with scientific research, such as example studying diseases. So instead of using one very expensive supercomputer, the project uses thousands of personal computers. It's connected through the internet. So this makes distributed computing a powerful alternative to supercomputers. So even normal computers can solve very complex scientific problems when they work together. So why distributed computing is important? Distributed computing is important because it allows us to solve large and complex problems faster. So it is also cost efficient Because instead of buying an extremely powerful computer, we can use many regular computers working together. That is why distributed computing shows how teamwork and technology makes problem solving faster, smarter, and more efficient. Let's move on to the next slide, the cloud computing. So cloud computing is a type of computing where data and services are stored online. So instead of being stored only on personal computer, because the data is online, we can access it anywhere. So as long as there is an internet connection, we can access it. So this is why cloud computing is commonly used by phones and tablets, not just computers. So before cloud computing, if your files were saved on one computer and that computer broke, everything was gone. Now with cloud computing, your files are stored on remote servers online, not just in one device. So even if your phone is lost or your laptop breaks, your data is still safe and accessible. So real life example of cloud computing. When we save a file in Google Drive or iCloud, the file is not actually stored inside our phone. It is stored in the cloud, which means on a powerful computer called servers that are connected to the internet. That is why we can open the same file on different devices. So kapag nakasave yung files, example sa iCloud or Drive, kahit anong phone na gamitin mo, you can still access it. This is cloud computing in everyday life. So here is types of cloud computing. So we have infrastructure as a service. That means infrastructure as a service. So this is when a company rents computer infrastructure such as servers and storage. So instead of buying physical machines, the users control the software while the cloud provider handles the hardware. So it's like we compare it. It's like renting a house, an empty house. You decide what to put inside. So next one is the platform as a service. So here, the cloud provider gives a ready-made platform where developers can build and run applications. So it's like the users focuses on creating software while the system handles setup and maintenance. So, di ba kanina, it's like renting an empty house. Ito naman, it's like renting a fully furnished kitchen. You just cook. So next one, software as a service. So this is where we use software directly through internet, so without installing it. So the provider manages everything. We just use the server or we just use the software. So ito naman, it's like ordering food. You don't cook na, you just eat. So here is why cloud computing is important. It is important because cloud computing makes technology more convenient because we can access our data anytime. It also allows people to work remotely, share files easily, and save storage space on our devices. So cloud computing changes the way we store, access, and use data by moving it from physical devices to the internet. Let's go now to the next one, computational learning or machine learning. Computational learning, more commonly known as machine learning, is a subfield of artificial intelligence or what we know as AI. So what this means is machine learning is one part of AI that focuses on how computers can learn, not just follow instructions. What do we mean by learning in computer? It means now, when we say learning for computers, we don't mean thinking or feeling like humans. Learning in the computer science means the ability of an algorithm to adapt based on inputs. In other words, the computer changes how it behaves based on experience. So, algorithm plus learning. So, machine learning is dedicated to the design and development of algorithms that allow computers to learn. So, di ba kanina, ang algorithm, it is a step-by-step method for solving problem. In machine learning, we design algorithms that improves themselves when they see more data. So this adaptability is often implemented using neural networks. So neural networks, it will be discussed later. So for now, think of them like as a system inspired by the human brain, helping computers recognize patterns. So there are several strategies used in machine learning depending on on the type of data and the goal. So machine learning means that computers learn from data. So what this means is that instead of programming every single instruction, we allow the computer to adjust its behavior based on the data it receives. So the more data the system sees, the better its decisions become. So part of artificial intelligence, so sinabi ko kanina, machine learning is a part of artificial intelligence. So artificial intelligence is the bigger field. So machine learning is one way we make AI intelligent. Not all AI learns, but all machine learning is AI. So uses patterns. Machine learning works by finding patterns. If the computer sees the same behavior, image, or result again and again, it starts to recognize it as a pattern. So this is how systems can predict outcomes, recognize faces, or recommend content. Types of machine learning. We have supervised, unsupervised, and reinforcement. Supervised learning. It is in supervised learning, the computer is given inputs along with the correct outputs. So we already know the answers. So the computer's job is to learn the relationship between inputs and the outputs. So if we show the computers many examples of emails labeled as spam or not spam, it learns the pattern. So and after learning, it can correctly classify new unseen emails. The next one, unsupervised learning. In unsupervised learning, the computer is only given the inputs, no correct answers. So the machine is expected to see a structure or pattern in the data on its own. And this is useful when the user does not know what the output should be, like grouping customers based on behavior. So unsupervised learning helps us discover hidden patterns. So we have, next one is the semi-supervised learning. Semi-supervised learning combines both the supervised and unsupervised learning. So some data is labeled, some is not. The computer learns from both. So this is useful because labeling data is expensive and time-consuming. Next one, reinforcement learning. Reinforcement learning is different from the others. It is concerned with how an intelligent agent should act in an environment to maximize reward. So unlike supervised or unsupervised learning, reinforcement learning does not rely on labeled input. So instead, the system learns from interacting with its environment. So if the action leads to reward, the system learns to repeat it. If it leads to a penalty, the systems avoid it. That is why reinforcement learning is widely used in video game, AI, robotics, and simulations. Let's go on to the next, which is computer vision. So, first bullet, understand images and videos. Computer vision is the field where computers understand images and videos. So not just see them, but understand what's inside them. So the computer looks at pixels, shapes, and colors to turn them into information. So it teaches computer how to interpret visual data the way humans use their eyes. So next bullet, recognizes objects and movements. So computer vision allows a system to recognize objects and movements. This means the computer can identify things like people, cars, or gestures. It can also track motion, knowing when something moves, where it moves, and how fast. This is why computer vision is powerful but also challenging. Third bullet, use and security. One of the most common uses of computer vision is security. Security systems use computer vision to detect unusual activity or recognize people. Instead of relying only on humans, machine can monitor spaces continuously. So, future of computer vision. In the future, computer vision can assist visually impaired individuals. So, systems can describe surroundings, recognize objects, or warn users about obstacles. So, this helps technology act as a second set of eyes. So, advanced security. Computer vision will lead to more advanced security systems. Instead of just recording video, systems will understand what's happening in real time. This makes responses faster and more accurate. Robotics. Computer vision is essential for robotics. Robots need vision to move safely, recognize objects, and interact with their environment. Without vision, robots cannot function intelligently. So computer vision enables machine to understand visual information and make intelligent decisions based on what they see. So let's move on with number 8, big data. First bullet, large data collection. Big data refers to the collection of every large amounts of data, not just a few files, not just spreadsheet. So this data comes from online activities, apps, websites, sensors, and systems. It is called big because traditional tools can no longer handle it efficiently. So used by companies. So big data is used by companies. Companies collect data to understand customers' behavior, trends, and preferences. So this include what people click, buy, search, or interact with online. That's why data becomes a business asset. So, third bullet, supports decision making. So instead of guessing, organizations use data to guide their choices. So decisions are based on patterns. It's not on assumptions. So this is the pros and cons of big data. So pros, medical search. So one major advantage of big data is its role in medical research. So large data sets help doctors and researchers track diseases, improve treatments, and predict health trends. When data is shared responsibly, it can save lives. While its disadvantage, however, big data is also raises privacy issues. So personal information can be collected without users fully realizing it. So the challenge is balancing innovation with ethical responsibility. So big data transforms massive information into insights, but it must be handled responsibly. So next one we have the neural networks. Ito yung sinasabi ko kanina, di ba? It's like a human brain. So first bullet, neural networks are inspired by the human brain. The human brain has neurons that receives information, processes it, and sends signal. A neural network copies this idea using artificial neurons to process data. It does not think like a human, but it learns in a similar structure. Second bullet, neural networks learn from examples. Instead of being programmed step by step, they are trained using data. For example, if we show a neural network many photos of our faces, it starts to recognize patterns. Their eyes, shapes, shadows, it improves through repetition, not instruction. So, bullet 3, neural networks are widely used in artificial intelligence or in AI. Kagaya na nga lang nung yung Gemini AI na uso yun ngayon, wherein we send Gemini AI our photo and then make a prompt saying make this photo more visually appealing, like that, and it will do it. So they allow machines to recognize, predict, and decide. So most modern AI systems depend on neural networks. So neural networks are powerful, but they also have limitations. They are hard to fix when they make mistakes because they don't follow clear rules. So they work best when given high quality data. That is why neural networks are used in face recognition, voice assistance, and medical diagnosis. So in short, neural networks allow machines to learn patterns from data, making intelligent systems possible. Let's go now to the next, or the last, tractable versus intractable problem. In computer science, not all problems are equal. So some problems computers can solve quickly even if the data is big. Other problems computer can solve them, but it would take years, centuries, or even longer than a human lifetime. So that's where tractable and intractable come in. First, let's talk about tractable problems. A tractable problem is a problem that a computer can solve quickly and efficiently. So even if the problem gets bigger, the computer can still handle it in a reasonable amount of time. These are problems we can realistically solve using computers. Now we have intractable problems. These are problems that becomes extremely slow as they grow larger. Even powerful computers may take years or longer to solve them. It doesn't mean the problem is impossible, but it is not practical to solve. So this is why some problems are avoided or simplified in real life. So this leads us to P versus NP problem. P problem are problems that computers can solve quickly, or in short, tractable problems. NP problems are problems that are hard to solve but easy to check once a solution is given, like intractable problem. So the big question is, can all problems that are easy to check also be solved quickly? This question is one of the biggest unsolved problems in computer science. So if P equals NP, many difficult problems could suddenly be solved fast. But if they are not equal, some problems will also remain slow to solve. So this affects cryptography, security, and optimization problems. So this is why some passwords are hard to crack and why certain problems don't have instant solutions. So tractable and intractable problems helps us understand what computers can solve efficiently and what remains challenging. So far, we talked about computing concepts like algorithms, machine learning, and neural networks. But now the question is, who studies these things and where do they belong? That's where computing disciplines come in. What computing disciplines actually means, computing disciplines are not just subjects, they are different roles in the computing world. They explain what kind of problems a person solves, not just what they study. So now we have the first one, computer engineering. Computer engineering is for people who want to work close to the machine itself. So they deal with both hardware and software, meaning they understand how the physical parts and the program work together. If a computer is slow, a computer engineer looks at both the components and the system design. They ask, how can we make this system faster and more efficient? So we have number 2, computer science. Computer science is more about thinking than fixing. So computer scientists focuses on algorithms. An algorithm is step-by-step ways of to solve a problem. So they don't ask, what button do I click? They ask, what is the smartest way to solve this problem? So this discipline builds the foundation of computing. We have the next one, information systems. Information systems is where computing meets organizations and businesses. This field focuses on how technology helps companies operate better. For example, managing student records, payroll systems, or online transactions. So the goal is not just technology, it's better decision making. So next one, information technology or IT. Information technology is the discipline that keeps everything running. So IT professionals manage networks, systems, and security. When system crash or network fails, IT handles it. They focus on maintenance, support, and protection, not just about theory. And lastly, we have software engineering. Software engineering is about building a large and reliable software systems. It doesn't just focus on coding, it focuses on planning, testing, and maintaining software. This is important because big software failures can affect millions of users. So software engineering treats software like a serious engineering product. So lastly, why mixed discipline exists? So in real life, problems are not simple. That's why mixed discipline exists. So modern problems need knowledge from multiple fields. Even healthcare uses IT, education uses software systems, business uses data and computing. So mixing disciplines lead to better solutions and innovation. Computing discipline shows us how different computer roles work together to solve real-world problems.
Good day everyone, I'm Fosaya Marie Marcos from BSE 1A, and today I'm going to discuss the computer discipline and majors and the software engineering. Computer discipline and computer majors are related, but they're not exactly the same. So let's identify what is the difference between computer discipline and computer majors. Computer discipline refers to the main fields or branches of study that focus on computers, computing systems, and information technology. It is the overall area of knowledge about how computers work, how software is made, how data is handled, and how technology is used to solve problems. Next one is computer majors. Computer majors are the specific courses or specializations students choose in their college under the computer discipline. So now, let's tackle what is computer engineering. Computer engineering students learn how to design and build computers, hardware and software together. They're focused on devices that use computers like cell phones, alarms, and medical machines. Programming is used to help these devices work and communicate with users and other devices. A big part of this field is embedded systems, small computers inside machines like ATM machines. This course is usually offered in engineering systems or engineering schools rather and needs strong math skills. Next one is computer science. Computer science covers everything from theory to programming and making new computer solutions. It prepares students to adapt to new technologies. Computer scientists build software, solve computing problems like data storage, networks, and security, and find better ways to use computers in areas such as robotics, computer visions, and that. Most computer science programs also need math skills. We have some paths here to tackle and explains its uses. Career path 1. Designing and implementing software. Making software, websites, apps, and systems. This is the most common job for computer science graduates. A bachelor's degree is usually enough, though some take a master's. Jobs are available in many places like companies, government, banks, and hospitals. Career path 2. Devising new ways to use computers. Creating new and innovative uses of computers. This may involve research, advanced studies, or starting new businesses. Some work in universities or research labs. Others become entrepreneurs. Career path 3. Developing effective ways to solve computing problems. Focusing on theory and algorithm to solve complex problems efficiently. This path usually needs a PhD and leads to jobs in research universities or research labs. And lastly, the career path 4, planning and managing technology infrastructure. Managing an organization's computer systems and IT infrastructure. This is the main focus of information technology programs. Now, let's move on information systems. Information systems focus on using computer systems and information to help organizations achieve their goals. Information students, professionals understand both technology and businesses, and they help improve process using IT. They act as a bridge between technical terms and management to improve organizational performance. Here are the important issues and businesses rely on IS, people to addresses. Please read it and analyze. Next one is information technology. Information technology is about using computers to support organizations like businesses, schools, hospitals, and government. IT professionals manage hardware, software, and networks, make sure systems are secure and work well, and some programming, mostly to connect or automate things. IT work needs tech knowledge, problem solving, and people skills. And lastly, let's tackle what is software engineering. Software engineering, or SE, is about making software that works well. It's reliable and meets customer needs. It's more than just programming. SE also teaches how to understand customer requirements, design, test, and manage software projects. SE students do lots of usable software. It combines math, computer science, and engineering practices. So, that is all for my discussion. I hope you understand and analyze what's inside my discussions, and thank you so much for listening.
So, ipagpatuloy natin ang ating discussion sa mixed disciplinary majors. So, ano nga ba ang mixed disciplinary majors? Ito yung pinaghalo-halong two or more subjects into one cohesive and single programs. So, ayun. So, why mixed disciplinary major exists? Okay. So, first, technology is used in almost all industries. Also, one skill is not enough anymore. And companies prefer people with multiple skills, and it helps solves real life problems. So ito nga pala yung mga interdisciplinary majors na related sa discussion natin ngayon, which is the mixed disciplinary majors. So meron yung bioinformatics majors. Bioinformatics major, by the word bio, it studies biology. So bioinformatics, by the word informatics, then is andun na yung computer science, no? And also, so in fact, sa madaling salita, ang bioinformatics is yung combination ng biology and computer science, kasi nga ginagamit natin yung computer to address the DNA and also to study genes and diseases. Involved din dito yung mga ginagawa sa hospitals, labs, and also sa medicine research. So next is the computational science, no? So by the word science, so andun na yung science and also math and computers. So ginagamit natin yung computers dito to solve science problems. And also, ginagamitan natin ito ng physics and chemistry, engineering, and weather prediction, which is yung weather forecast. So, ayan. And next is the computer science and mathematics. No, it combines computer science with mathematics, of course, sabi dito. So, it is for students na mahilig sa logic and also sa mga numbers, no, kasi involved dito yung mga programming, data analysis, and also the research. And it is the study of computers and how to make them solve real life problems using programs, algorithms, and data. So next is yung gaming and animation. Okay, These majors these majors have various flavors and may combine either or both of computer science and information technology, work with either or both of art and digital or media studies. So dito, no, kapag pinag-combine natin yung gaming and animation, it becomes more engaging and realistic. So um ito din nag-help din ito sa mga artists na mag-produce ng movies, ads and digital content na magbibigay sa kanila ng kita. Diba? And next is yung medical informatics, no? It is the programs for students interested in work in a medical environment. So, 'di ba, by the word medical pa lang or health informatics is andun na yung medicine and the combination of IT and medicine, no? So, computers used in hospitals. Ito yung mga computer na ginagamit natin sa hospitals para para ma-save natin din yung mga information or personal information ng patient natin para less less fail na baka sakaling mawala lang kapag soft copy, pag hard copy. So need na i-save talaga dapat sa computer. So it manage patient records, lab systems and hospital data. And bakit nga ba sila nga importante? So sa bioinformatics muna, bakit siya importante, no? Ginagamit yung bioinformatics, biological data is too big and complex to analyze, and also it speeds up research and reduce cost. And sa computational science naman, some problems are too dangerous, expensive or slow to test, no? And computers can test many scenarios quickly, and it helps make better decisions and predictions. Since computer science and mathematics, because bakit nga ba siya importante? Because it is the foundation of science and engineering. So meaning nagkakaroon kasi doon ng mga 3D structure na kung saan is nakikita nila yung structure or yung building na pwede nilang ipatayo. So dito naman sa gaming and animation, bakit nga ba importante? Because it boosts our creativity and storytelling, and it combines art and technology. Sa medical or health informatics, it serves time for doctors and nurses. So ayan, dumako naman tayo sa computing knowledge areas. Pag sinabi natin computing knowledge areas, it is the major fields or domain or study within computing. It is also the branches of computing. Ayan. So, ito yung main computing knowledge areas. It includes computer engineering, ito yung pag-build or improving computers and electronic systems. And ano yung ginagawa nila? They focuses on hardware and also to the software and circuit design and electronics, and also the embedded systems. Or is computer science, no? A unique aspect of the current computer science curriculum is the CS 2013. It is its inclusion of course example from many diverse universities which show different ways in which the curriculum recommendations can be implemented. So example niya is the mathematics, electrical engineering, psychology, statistics, fine arts, linguistics, and physical and life and sciences. Okay? So, nag-add pa sila dito ng mga several knowledge areas to those defined in its predecessors. So, they include information assurance and security, networking and communication, platforms-based development, and so on. So, next is the software engineering. Discipline or designing. It's discipline of designing and developing, testing and maintaining software. So sa madaling salita, software engineering is building the software the right way. Okay, so and dito rin makita nandito yung meaning ng SEEK or yung SEEK, which is the Software Engineering Education Knowledge. So, ito yung mga ano niya, mga discipline niya: information, terminology, artifacts, data, rules, methods, models, and so on. So, ito naman yung the 10 knowledge areas that make up SEEK. No? Ano ulit yung SEEK? It is the Software Engineering Education Knowledge. So, computing essentials, mathematical engineering, professionals practice, and so on. So, dumako naman tayo sa information technology. It is the use, management, and support of computer systems, network, and software to store processes and transmit information. So, information technology is using computers and networks to manage information. No? So, makita dito no yung it includes dito sa may IT 2008 yung user advocacy skills, the ability to address information, and so on. So, lastly, information system. No? It is a structured system that collects, processes, stores, and distributes information para mas mapadali or makapagbigay tayo ng kaalaman sa ibang tao and para matulungan natin magdesisyon yung ibang tao. So, it is a system that turns data into useful information for decision making. No? Yung components pa dito yung IS is the hardware, software, data, people, and processes. No? So, ayun lamang po. Salamat sa pakikinig. Paalam.